Hello everyone, this is ESTR 1004 project. We are the group Jellyfish. Alright, in this video, we will talk about creating a schedule. So, why we should create a schedule for the transportation system? Let's look at the news. If the system is not controlled properly, there may be some unexpected things or even dangerous things happening. So, it's important to create a good schedule. This is our catalog. Firstly, we would like to talk about simplex method, an important way to do linear programming. Let's see an example. Let z equal to 40x1 and 88x2. The constraints are 5x1 plus 2x2 is less or equal than 60. x1 is larger or equal than 0, and x2 is larger or equal than 0. Our goal is to maximize z. So how to solve this problem? We rewrite them as three equations and we get an augmented matrix T0. Let's look at row 1. The first negative number is minus 40 in column 2. Then we compare 60 divided by 5 and 60 divided by 2. Obviously, 60 divided by 5 is smaller, so we use row 3 to eliminate row 1 and row 2, and we get a new matrix T1. Repeat this procedure, we get matrix T2. Then there is no negative number in row 1, so the maximum of z is 840. That is simply simplex method.
This is the introduction of our project. Our goal is to create a bus timetable that minimizes average commute time in a small city. However, transportation is a quite complex system and we should consider many variables like operating time, number of passengers, costs, fares. To simplify our model, we should make some assumptions. Here, we introduce some important hypotheses. For example, the bus loading rate does not exceed 100%, not less than 50%. The bus enterprise won't lose money. In other words, the profit is no less than zero, and the speeds that passengers entering each station are the same at a certain time and their destinations are uniformly distributed. Here are some variables used in our project. T is the time interval between two buses. Then we begin to analyze the optimization problem. As we all know, the commute time consists of waiting time and the time spent on the buses. However, we cannot minimize the time spent on the buses, so what we should do is minimize the waiting time, and we can calculate the average waiting time for one people is T over 2. Then we get a form which shows the number of passengers getting on, getting off, and total passengers on the buses at each station, when n is an even number. The number of passengers reaches maximum at n over 2 th station, and when n is an odd number, the number of passengers reaches maximum at n minus or plus 1 over 2 th station. according to our assumption that the bus loading rate does not exceed 100%, not less than 50%, we get the inequality 1. Then we consider the fares. We can calculate the fares in a single journey and thus calculate the total fares F in one day. Then according to F, C0 and C, we can calculate the total profit in one day W. Let W be larger or equal to 0. We get the inequality 2.
Okay, now based on the inequalities, we can do linear programming through the simplex method. First, we add 3 basic variables. Then we can figure out the result following the steps. Here is an interesting thing. We take the east rail line as our model and use the trains to replace the buses. By assigning some values to some variables and minimizing t, we know that t is 306 seconds. These are the running times we measured on MTR. These are the files of MTR in reality. Based on these statistics, we can create a schedule like this. These are the reference. Okay, that's for this video.